Okay, hello everyone. I'm gonna assume that you all can hear me. So welcome to the 76th week of Re-Knowledgeable. For those of you who are joining for the first time, this is our internal podium that we share things we find interesting as a React developer. Here in this we have a bit.ly link to the event details of today's event. You can find the link to our talk as well as the slides later on. We will update and also the links to the videos later on. So shouting out to Shopee, who has been hosting us, as well as engineers, SG, which has generously provided guidance and supports to all our recording and live streaming. We do have a COC, by the way. If you just joined the YouTube stream, right now is the time for you to say hello to everyone. Do not record our live stream. Do not post advertisements. Say nice things to each other. Make friends. Socialize. And if you want to do sharing at RK, please use this link to create an issue for your topic. We're currently working on schedules for July, as well as slightly earlier than that also. So yeah, if we do have a lot of new joiners lately, so please note that we really welcome you and encourage you to give sharing at this podium. The least thing I want you to feel like is that this is a podium for senior members. Actually, it's not. If you find something particularly inspiring and things you have learned as a developer here, please do consider doing a sharing at this podium. If you're joining as an intern, choose your tasks wisely such that at the end of your internship, you have something interesting to share. Actually, previously, we did have one intern who did her exit talk, exit presentation at as one of the RK sharings earlier on. She talked about CSAST. Yeah, so we're really looking forward to having more of the sharing from you also. And yeah, so also we welcome topics sharing from people who are not even in Shopee. Please still use this public link to let us know if you have anything you want to discuss with us. Okay. Right. So yeah, and finally, if you're already working at Shopee, please do not wait until I harass you for a topic. Please start working on things you find interesting lately and let us know that you're doing a sharing. Yeah, so enough of the harassment now. So Singapore CSS happened 2 days ago. This is the first time I missed this myself because I was fighting with like 5 projects. I don't know at the same time, but check out the link for videos for the talks for this month. And then next month it is happening first day of July, number 52. I believe it will keep happening in the interweb because COVID isn't going away. So check it out. Check out Singapore CSS, amazing meetup in the local community.
Chloe,
So yeah.
sorry to interrupt. I think you need to share the screen.
Oh, really? Okay.
Yeah.
Oh my God. Okay. Let me do the screen sharing again. Okay. The first page, RK link, bit.ly link to the event detail. Second page, shouting out. Third page, COC. Fourth page, schedules. Actually, no, not schedules. Link to proposing a talk at RK. Right, Singapore CSS. Check out the website and check out the log for the past event. And then, yes, finally, we're at today's topic. So today, Adrian from our team, he is building a toy web browser. So I think in his proposal, let me show you. once upon a time, an interviewer asked him what happens behind the scenes in a browser. That's a classic interview question. And I would definitely fail this interview if I was asked. And I'm definitely once was scared about what is happening behind the browser. But then this one is a superb attempt at trying to um, understand it by building this ourselves. So with so I'm gonna pass it on to Adrian. Please welcome Adrian. It will be his first talk at RK, and please give him all your support. Okay, Adrian.
Hi guys, thank you for having me here. And today my topic is about toy browser. So this is just a simple model to demonstrate how web browser renders HTML string into a graph in your screen. So firstly about me, I'm Adrian. I work in Shopee web team, and I love soccer, PUBG, and Dota 2. So one of the fun facts is that a long time ago, I played professional Dota for about 6 months. Okay, so let's start our topic today. So what is our objective to build a toy browser? It's simple. We just need to turn a server-responded HTML string into an image. Okay, so what does this to do with a state machine? Maybe as you know that both HTTP protocol or our HTML, they are all string or text. So today we are going to use a lot of state machine to process this text. So let me give you a recap of a state machine first. So what is a state machine in stream processing? Okay, so here we have a simple problems. We want to match pattern B. We want to find the occurrences of pattern B in our main string A. So this time we got to do it with a state machine. Okay, so as usual, we have a match function. This match function will accept a string. And in this while loop, okay, in this while loop, we'll recursively feed all the characters of this string to our state function. So how does our state function looks like? Okay, so for the first character, we expect it to be A. So you can tell from its function name. So we start with expect A. Okay, if your next character is A, then the state flows to expect B, and so on and so forth until it reaches the last one. If A, the intermediate process, is not the character we expect, we just return back to expect A. Okay, so if all the string matches here, then we return a null for it. Also, in here, we will detect if the current state is null. A null means that we have found a match in our main string. So this is just a simple idea how state machine are used with strings. Okay, so let's start create our toy browser. So our work will include 5 parts. The first one is pass HTTP response. And then we have HTML tokenization. And after HTML tokenization, we will have a DOM tree constructed. So we are going to match our CSS with our DOM element. After the DOM element matched with CSS rows, then it's time for us to calculate the layout. Okay, so layout will give us the position information of our DOM element. Then we are good to do the rendering part. Okay, so let's start with the first one, pass HTTP response. Okay, so for our modern browser, they always provide the API like XML HTTP request for people to use to initiate an API request. So for our Toy browser, we'll also provide such an API to send out HTTP request. Okay, so this is how our request class looks like. So let's start with the constructor function here. Okay, there are two parts. First one is you pass in some configuring options. This part is used for TCP collection. And the next part is that we need to send some we need to set some headers for our HTTP request. Okay, so you see here we set a default for content type if the user doesn't parse one. And in here we do some body text string file because finally you need to parse the serialized information over the network. Yeah, okay. So what does this serialize function do of the request? So people, you may know that for HTTP request, this is the format we need to send out over the network. So this serialize is just to format your options into a string so that it can be sent out through network. So for the first line, we have the request line. It consists of your HTTP method and your parse, and also the version. Okay, so followed with a /r/n becomes the headers part. Okay, so please take note of this /r/n. This is quite important for HTTP. And then we follow the empty line here. Then comes our body part. Okay, so we have done a lot of preparation work for our request. Then we will send this out. So before sending out, we will create a TCP collection for it. And after the TCP collection created, we just write all the stream over the TCP layer. And we bind a data event here for the server responded information. Okay, after we get all those response test stream, we resolve it. Okay, so let's see the demo here. So to start, we need to have a simple HTTP server. So this is a very simple HTTP server created by Load API. So I just start it up. Okay, so for here, we have some client code. So this is all the code I just showed you, right? Okay, here we construct a request, then we send it out. Then let's print out the result. This result should be the HTTP response stream. So let me take the client. Okay, so you guys can see this is what the server responded. Okay, so let's go back to our slides. We have successfully so we can successfully send out a HTTP request, and we get the response from server. Then we have this piece of a string. So what does this stand for? So this one is a status line and the headers, and with an empty line, we have a body. Because our body was transfer encoding with chunked format. So the format looks like this. It's start with a chunk less. It means how many characters follows it. So for this is a hexadecimal, so it should be equals to 11. So hello world, the length is 11. And if we come with a 0, it means that our body ended. So, okay, just text makes less meaning for us. We need to parse it to be a computer understandable object. Okay, so a larger state machine for us to pass in the response stream. So in here, we defined some state for it. Okay. And our state machine starts with waiting status line. That means we expect the first line is the status line. And all those variable is the intermediate result used to emitting result. So this is how our response parser looks like. So you can see it's the same structure. We have a for loop to feed all those characters to our receive character. And this receive character will dispatch all those characters to corresponding state functions based on current status. So all those parse status line, all the parse handle value are status functions. Okay, please take a look here. We have a body parser, but it's a independent class. Why we are doing this? Because as you know, we have so many content coding methods in HTTP. Yes, we are familiar with gzip or deflate or compress. So for different content coding type, we have different body parser. This is to decouple our body parser from our response parser. So it makes our response parser to be extensible. Yeah, that is the design. Okay, so let's look back our demo here. So this piece of code never changed. So we add the response parser. We just add it here. Yeah, we turn this data to string, then we parse it. Then we get all the result from it. And we resolve this response to users. So let's run the client again. Okay, so you can see this is the raw stream, and this is the one parsed by our response parser. Okay, let's continue. So now we can successfully get the response body from our HTTP request. So next, we need to pass the content, which means the HTML tokenization comes first. Okay, so for HTML tokenization, it's also a state machine. The template is almost the same. It's just a for loop, and we pass every character of our HTML string to the state function. So how does our state function looks like? There are so many state functions. You can indicate the functions from the name, what they are doing. So for example, we have tag name, before attribute name, after attribute name, attribute value, and to tell if it is a self-closing start tag or not, such as the image element, it is a self-closing start tag. Okay. So you may wonder, how does the state function work? How I author all those state functions? Let's take the tag name state function as an example here. You can see here, based on the different character type, we have different processing logic. Okay, actually, you can just refer to the HTML specification to write out this state function. Yeah, just transfer those specifications to code. For example, if your character is a tabulation, or it's a line feed or form feed or space, you switch your state to before attribute name if you are in the tag name state. Okay. If you comes with a backslash, it means that this is a self-closing start tag. Yeah, you just follow the specification and do the state transition. If it is a ASCII character, you just append this character to the tag name. Also here is just two lowercase because the specification required that the tag name to be lowercase. Yeah, so the specification covers you well. If we click into this link, you can see there are so many state functions. Let's go to the categories. Okay. You can see there are so many state functions. So I just picked a few of them. Okay, this is how I write this state function. So you may notice that here is the emit function used to emit our tokens during the tokenization. Okay, so we have a stack to restore all the intermediate state during our element traversal. And based on the token type, we are doing different things, such as if this is a start tag, that means that we encountered a new element. So we initialize a new element, and the top, okay, the top is the stack top, means the top means it's the element, it's the parent of this element. So we push this element to its children array. And here we are doing something else. We check if this is a self-closing tag. Yeah, if this is not a self-closing tag, we push this element to stack because it means that this one may have children. So we need to reserve the state. And okay, for here, if it's an end tag, that means the previous one can be popped. So this is some kind of DFS. Okay, and also we have text node. Yeah, so just based on the token type, we have different process logic. If this code is too small, I zoom in it for you. Let's say this is a data structure of our element. It have tag name, it have parent, and its attribute, and what is its children. Okay. So this is just some text load. We just appended the content to it. So the output of this step is that we will generate a DOM tree, and the tree structure looks like this. Okay, let's do the demo here. So we have our HTML parser here, and this is all the code just in our slides. And we have so many state functions, and we do the parser. So we do the parser. Yeah, we get the response from previous step. So we parse its body, and we construct out a DOM tree. And we console log this out. To avoid any circular dependency during our JSON string file, I just turn this parent to be tag name. Okay, so let's run the client. Okay, so this is a whole DOM tree. So we have a root node called document, and all the other elements is to be children of it. Let's see, this is our HTML. Let me find this container one. Okay, you see this container element. It has two children, which means it has two children. One is my ID, the other one is class C1. And its parent is body. And its tag name is div. Yeah. And there is a children array, which is this two. And okay. And here you can see there's a sequence number. This property just marked the sequence. This one means I'm the 0th children of my parent. Yeah. So what does this use for? This will be used to check your symboling element. Yes. So this is the output of this step. Okay, so we successfully construct a DOM tree. So next, it's time for us to build the CSS. Okay, so this is our CSS text. And here we used a third-party npm package to do the parsing part for CSS, because this part is another topic. They use the LR algorithm to parsing CSS. So I just use a third-party package to do this. So after this function, these rows will be filled such content. As you can see, I take this section as an example. It have a selectors, means container my ID, and another CSS declarations here. There are 3 of it. So now we have the CSS rows in this array. Okay, so next step is that how we match those CSS with our DOM. Firstly, I want to introduce 2 functions that during the process. One is match. So this match will accept 2 parameters. One is a DOM element. This should be the element we get from the last step. And we have a selectors. And we will check if this selector, if the CSS selectors match this element or not. If it match, yes, we are doing something. And also here is a specificity because there may be multiple CSS select to match our DOM element. So the declarations may have different priority. So in here, we define the priority of the CSS rows. This, you can see the weight is a four element tuple. The first one stands for the inline style element. It takes the most hit. Okay, the second one is ID select. The third one is a class select. And the fourth one is a tag name. So you see, we didn't consider other such as the attribute selector or the universal selector. This should be considered also, but in our toy browser, we just consider 3 cases here. One is ID class, and for other things, take it as a tag name. So it do the specificity. Okay, so how this two function was called? In this compute CSS function, firstly, we will check if our element matches current CSS rule. If it's a match, then we calculate the specificity. Okay, then we assign the CSS declarations onto our DOM element. And during the assignment, we will check if it have a higher specificity. If it is, we will override the old value. Okay, so for this match function, I have a working version in the real environment, in the modern browser one. So let's take this. Let's take Shopee's website as example. Here. Okay, let me just copy paste. Let me copy all. Okay, so now we have a match function. So let's take something as example. Okay, how about we take this DOM element? Let's put it to CSS for home banners. Okay, so I just press $0. Yeah, so it means that this CSS selector can select this one. Okay, let's look back a little bit. How about we select this row main? Okay, so let's select this one. Oh, why it seems there is a problem here. Let me take this one. Be div. Okay, so it seems this Spark, this code have some problems. Yeah, so I want to say that this match function just demonstrate how it works to check if the CSS selector matches our element. Yeah, so if you are interested, you can play it after this sharing. So for time concern, so let's continue with this. Okay, so the output of this step is that in modern browser, we have computed style. So if you go to inspector, you can see there's some CSS a statement was override by others. So this is the how specificity here. So for our toy browser, we will add a new property named computer style to our DOM element. So this should be our output. We will add another property for our DOM element. Okay, let's do the demo. Okay, so okay, immediately after we initialize this element, we will compute CSS for it. Okay, so this computer CSS will try to add a CSS declaration to our DOM element. Okay, so for here is where we start to collect the style sheet for it. So if the end tag name is style, it means that we collected some style row. So this add CSS row will add all those style to our array, to this array. See? Okay. So let's run. Also, let's take this container to check if we have any. Oh, you see this computed style here. And for our container, we have some CSS rule here. The first one is the value. The width is 500. And the height, the display property, and the background color. And each of them will have a specificity. Because this is the ID selector, so here we put 1 here. Okay, so let's go back to our slides. So from the previous 3 steps, we have already successfully parsed the HTTP response and do the HTML tokenization. Then we matched our CSS to our DOM. So now it's time for us to do layout. Because we have CSS rules, we can do the layout now. Okay, so there are 3 generations of layout technique currently. The very first one is a normal flow. Okay, so your document just layout from left to right, from top to down. If your writing mode is from left to right, this should be affected by the writing mode also. But normally the layout is from left to right, then top to bottom vertically. The second one is that the flex layout. So flex layout is a one-dimensional layout technique. Okay, so this one has been heavily used by RN, and RN proved that flex can satisfy all the needs currently we have. And the third one is a grid layout. Okay, so last time ago we did a sharing on grid and how he used the grid layout to draw this cute pixel logo. If you're interested, you can revisit it. So for our toy browser, the flex layout is the most easy one to be implemented. So I choose the flex layout to be our layout solution for our toy browser. Okay, let's see how we do it. If you check the documentation, this is how the documentation defines flex layout. It have a main axis and a cross axis. So this is a 2 direction. For this 2 direction, we have 10 variables. Okay, so the main size means the element size along the main axis. And the main start means the start, we start from left or start from right, and the main end. Okay, the main style means it's a direction of our layout. So it means you lay out from left to right. If it is a negative value, means you maybe lay out from right to left. So such as the flex direction to be row reverse. Okay. So all those 10 variables is just abstraction of your layout. And based on different flex direction, you give them different value. So your logic behind the below this can be unique. So this is a abstraction layer. Okay. So our layout starts from the step 1. We want to collect all flex items of a container into its rows. Okay, so it may look like you place the first one, you place the second one, and you place the third one. Okay, at this kind of a moment, you have two variables. One is the main space. It stands for how much room still remains for you to place the next items. And also the cross space means the height of your container. So you can see here the height is decided by the highest item in your row. Okay, so at the end, if the main space larger than 0, that means that we have some space remaining. So we will assign those extra space to those flex items based on your flex growth. Yes. If it is less than 0, then we are trying to shrink those children items. Yes, this is how the layout along the main axis was done. Okay, then after it, we need to calculate the layout on the cross axis. So firstly, we will define the line height. Yes, it also can be achieved from a previous step. That means the highest item. And after that, we need to determine those items' position along the cross axis based on the CSS properties, such as if this line itself is center, we just move this block to the center position. If this if the line itself is a flat end, then we move it to the bottom of the container. So this is just the basic idea behind the layout. So just in general, there's 2 steps. One is the main axis, the other is the cross axis. So what is the output of this? So for a modern browser, if you try to check the bounding client rect, you will get an object with this matrix here. Okay, so this property defines a rectangle's position and the size. So you know where to place your element in your browser page. Okay, so also for our toy browser, we may add a property named style to our DOM element. Maybe this property name should be position or something else. Yeah, but finally we need to add another property to our DOM element, and also it have this kind of position information. This will be used for our render. Okay, so the layout. So for layout, we'll just calculate all those 6 metrics to define the position of our rectangle on our page. Okay, so let's do the demo. Okay, so let's go back to our HTML parser here. So when does the layout calculated during our emit token? It was done at end time because at this moment you know how many children you have for a parent, so you can do the layout. Okay, remember that this top means the current parent. Okay, so in this layout here, we have some default props. If you didn't set a flex property for them, we have some default for it. Okay, we defined the abstraction variable for our layout. And based on different flex direction, we have different values for all those 10 variables here. Okay, so the code may be, yeah, so this is just doing the layout. Okay. Let's check our result. Okay, so this is a computed style we get from the last step. And during layout step, we use the computed style to calculate our position information. You can see the final coordinates matrix for our element is assigned here. We have height, width. 4 rows didn't have other properties. We have a default value for it. Okay, let me take a good example here. Okay, how about this one? You have left, right, top, bottom, height, width, and with all those information, you are good to do the render. Okay, so this is a layout step. Okay, so finally we can render it. So for render one, I use a image package. This one can take in your width or height and the position maybe, and fill all those color values because we have RGB, so it will fill those values. And those images will turn our position information into bitmaps. So the output of our render should be an image here. Okay, let's do the demo. Okay, so this is our client index.js. We have required these images in. And before we rendering, we need to define a viewport for it. So our viewport is 800 width and 600 height. And we pass HTML here. And then in this render method, we parse in the viewport and our DOM structure. So how does this render looks like? Yeah, it's just called the images API. And if this element have any children, then we recursively call the render method for its children. So finally, we can get a bitmaps image, which is described by our HTML string. And we save this viewport to our root folder. Okay, so this is our HTML. Then we start to run our So you can see this is a final output. Let's do some change. They are squeezed together, so we in H. Okay. Yeah, so okay. Let's say this two blue block should be this A. So we may align self align or not self. Yeah. Okay, so that is the whole process. So let's verify it in the real browser to see if we are doing the right. Okay, so I just replace all the HTML to be our HTML. Okay, as you can see here, this is the whole process. Yeah. Okay, I think that's all for me. Thank you for listening.
Wow, am I joining the? Wow. Okay. So thanks for this sharing. There are actually people are more excited than you look like right now. You know, there's like yeah, there's like multiple celebrations going on, and people are like super amazed. Like people are saying that this is the most ambitious talk that we're having in the meetup. Right. So got any questions from the audience? Actually, we were also talking about so you were there for Jenny's dry run, right? So we were talking about the CSS and the HTML parsers. We were like, that's that's the exact content we wanted for Jenny's sharing next week, because she is gonna. Okay, so preview for next week. We have a talk about parsers. So remember we did the tokenizer today for the HTML and CSS parser here. So we might have some content for you next week that talks about how potentially we can do that, like in a with a senpai's wisdom from a guy named Early. So yeah, okay, we do have questions. The first one, I think both one from Aaron. So first one, do you handle the case where width is not specified?
Way is not specified. Regarding which part?
I believe it's regarding the layout as well as the rendering part. With
Oh, so you mean if I take all the situations of layout?
let me. So I think my understanding about the question, because we did put down a width for the container, right? So do we handle the case where the container width is not specified? Because for Flexbox.
Oh yeah. So, oh okay. So
well, Singapore CSS is saying it's not practical, but let's see. Yeah, how do we do this potentially?
Okay, so if you didn't set a width for the container, then I take this one as an auto sizing. So
so we did.
Yeah, so we did a for loop. okay, end up all the children items width, and the width will be the final width of the container. So there will be an auto sign here. Yes.
Wow. So is it following the pseudocode from the CSS specification for Flexbox?
Not really.
Okay. Wow.
Okay, so I can say that this code may have a lot of edge cases not handled because I didn't got it with some unit test or something else. So for this part, it's just I mean a general idea how the Flex doing the layout and how and at what moment HTML is insert the layout information to our DOM. Yeah, so maybe this to be a follow-up work. If it is interested, we continue work on it to make it perfect.
Nice.
Oh yeah, so do expect some edge cases not handled. Yes.
I see. Wow,
yes.
cool. Next step will be to implement the. Okay, so here in Singapore CSS, again, we can implement it by following the algorithm according to the CSS specification. Yeah, so that can be a next step. We do have more questions. Let's clear the questions. Okay, I'm just gonna follow the order. So, what's your plan on handling text? Right, because we're doing the rendering using an image library, right? So how to handle text?
Okay, glad you guys asked it. I tried, but it's quite a huge topic, I think. So, you know, text, you can see text is also an image. It's also a box. It also should be a step of layout. And to lay out those text, you need to check this free type. Okay. And basically, I cannot find a low-level library to help me to do this because, yeah, so to render text is another quite big topic. Yes, so you have different glyph here, and those glyph is actually some bitmaps. Yes, for different sets of this glyph, it also have layout information, but all of the layout information should be related to the left, top, or right, such kind of thing. So when you see a browser renders this text for you, it just a lot of rectangles, yes, layout for you by browser. So yes, that is why we cannot render out a text here.
I see. Wow, that's
out, yeah.
That's like another peek into how complex this whole process actually is. Right. Okay. Next, while you are building this toy browser, which part is the one that confused you the most? This is a question from Yichin.
The CSS match part.
CSS matching. Oh,
yes.
Is it about the specifications?
No, it's I mean for this match function.
Okay.
Because you know, I don't know such as if you have some selection like nth last child. Yes, I think I just supported a few of the a fraction of the CSS properties. There's still some other CSS properties that I cannot implement by just use this match function, because you see this nth last, it may cause some traceback during your tree traversal. So if you check the compatibility issues of CSS properties, you can you may can understand that why some of it have a poor compatibility issue. Yes, this is
Okay.
this is a constraint behind it. So I think in CSS4 there are a lot of CSS properties related to traceback or some kind of those statements was not completed by most browser yet, because that's the reason behind it. So to answer Ichin's question, I think the matching part is the most challenging part.
Wow, I see. That's also like, it's like a challenge for browsers in general, I guess, not just for this project. Okay, next question. I know it's 7 already, but let's clear the questions. I know people are really, really very curious about this this topic, like I am. Right. So, okay, I'm losing track of the chats. How to implement JavaScript execution? He actually proposed eval. Is that what you're gonna do? This is a question from Carrick, by the way.
Oh.
And Sullivan also.
Actually, I have no idea how to do it. To be frank.
Well,
so if you check the source code of Chromium, and you can see that browser is a huge engineering project. And just for this HTML, you can see how long the source code. Yeah, and I think if you are interested, you can check this. Check the source code. I think there's a JS call or something. Oh, sorry, I cannot find it. And okay, sorry for CSS. There's so many source files. So if you curious, you can try to read all of this. There are plenty.
Well, just thinking out loud here. So for a real browser, it should have like some kind of JavaScript engine inside, right? Like a V8 engine. So for our case, since we're building this toy browser in a Node environment, is it possible that we utilize like the Node environment that we already have to somehow execute the JavaScript? So just thinking out loud here, I'm not even sure whether I'm making sense or not. But...
Actually, I'm not quite sure about this part.
Okay, no worries.
This is quite beyond my knowledge. I think it have something to do with the virtual machine, the sandbox. Yes.
Yeah. Sandbox. Oh, okay. Well, let's skip this. Let me see if there is any. Am I missing any questions? Please remind me here if that's all the questions we have. Let me wait a little bit. I think we are covering all the questions now. Right. Okay. So let's wrap this up. So thanks again for this amazing sharing. I'm actually amazed at how slowly you're going, but how much like of the understanding that you're actually like building into my brain. So I am completely amazed at this whole process. So I guess the best way to understand something complex is to try to build this ourselves. Right. So thanks again, Adrian. We're really hoping to see a follow-up on this. Please do let us know if you built any more of the stuff on top of this. And I'm pretty sure we might we can even have curious people who might be interested in building this together. So that concludes our event for this week. Like I mentioned previously, next week we'll have some sharing that is somewhat relevant. So stay tuned. And I'll see you next week. Bye, guys.
Bye-bye. Thank you.